All right, hello pre-calc students. So modeling and solving problems with pre-calculus functions. Note that the entire pre-calculus class test core questions are, yes, Kevin? Oh, I need to unfreeze. Yep. So your pre-calculus questions are calculator active, and sometimes while you can solve things algebraically by hand, when time is a factor in these tests, you got to learn how to evaluate these problems with a calculator. All right? So some of them are going to be efficient with a calculator, some of them are not. So let's do this problem. Negative 4.9x squared plus 8x plus 12 is equal to 7. Now, one thing I can do is I can subtract 7 from each side. So I get negative 4.9 x squared plus 8x, and then 12 minus 7 is going to be plus 5. So this is actually, and this is equal to 0, and because this is equal to 0, I can find the zeros of this polynomial in my calculator to find out when x is equal to 0. So let's pull up my calculator. I'm going to go to mode. I'm going to go back to function mode. All right, I'm going to go back to function mode. I can use y is equal to negative 4.9 x squared plus 8x plus 5. All right, and I can graph the function. All right. When I graph the function, I'm gonna should have two zeros. All right. So I can use second calc, find my zeros, and I see my two zeros is when the function intercepts. So left bound, I choose a point to the left of the 0. Right bound, I choose a point to the right of the 0. And then for my best guess, I try to choose a point that's close to the 0. And so I'm going to have one 0 at negative 0.480. So one of my zeros is going to be negative 0.48. So x is equal to negative 0.48. My second 0 is going to be second calc 0. My left bound point is going to be to a point to the left of my 0. My right bound point is going to be a point to the right of the 0. And then my guess, that's my best guess for the 0. So when y equals 0, x is equal to 2.115. So 2.12. So my other guess is going to be x is equal to 2.12. To show all work, I'll do, to find my zeros, I'd use my calculator. All right. And then in my calculator, I did second calc 0. All right, let's all right, so I used my calculator. I went to second. Geez, this is all over the place. I did to second calc, and then from there I found the zeros. All right, so that's 72. For 73, you need to solve for x. I have x minus 5, the square root of x minus 5 minus 6 equals 12. Add 6 to each side. The square root of x minus 5 is going to be equal to 18. All right. I square both sides, yes? Yeah. I square both sides, so x minus 5, square root of x minus 5 squared is x minus 5.
Cancels out 18 squared.
18 squared is 324. Add 5 to each side. Alright, so x should be equal to 329. So just note that 18 squared is equal to 324. Alright. For 7. Alright. So now we have 74. With 74, 2 times 3 to the 4x equals 20.
Divide by 2.
Our goal is to isolate x. So our first step is to divide by 2.
Yeah.
The 2's will cancel out. So 3 to the 4x is equal to 20 divided by 2, which is equal to 10. Now, in order to get the x out of the exponent, what we have to do is convert our exponential function into a logarithm. So we have the base of our exponential function is going to be the base of the logarithm. All right. Then we swoosh. Can you guys please be quiet and focus on work? So you have the base, and then you go across the equal sign of 10 is going to be equal to 4x. So putting it all together, you will have log, the base of the logarithm is 3, of swoosh, there it is, 10 is equal to 4x. So to isolate x, we divide each side by 4. So x is equal to the log base 3 of 10 divided by 4. And that is the answer. Alright. For 75, you have 2 times the log base 3 of 2x equals 25. So you divide each side by 2. You have the log base 3 of 2x equals 12.5. Alright. You turn our logarithm into an exponential function. So 3 swoosh to the 12.5 power is equal to 2x. So x is equal to 3 to the 12.5 power, all divided by 2. So that's 125. That's 3 to the 12.5 power.
Wow.
So that's right. So that's 75. For 76, we need to get things into a partial fraction. So you have, what we need to do is add to get a common denominator, okay? So you will have, to get a common denominator, we will have 2x over x plus 3, and then in order to get a common denominator, I'm going to multiply this by x minus 6 over x minus 6 plus 3 over x minus 6. I'm going to multiply this by x plus 3 over x plus 3. And this is going to all equal 27. And when I factor x squared minus 3x minus 18, that's going to give me x minus 6, x plus 3. And the reason it gives me that, the reason why this trinomial factors into x minus 6, x plus 3 is negative 6 plus 3 is negative 3. Negative 6 times 3 is negative 18. Yeah. All right. So this is going to give me x minus 6 times 2x is going to give me,
X squared.
yeah, so it's going to be 2x squared minus 12x plus 3x plus 9 is equal to 27, and this is all over x minus 6, x plus 3. X minus 6, x plus 3. And what I can do is I can multiply each side by x minus 6, x plus 3. And when I do that, I'm going to cancel out my denominators. Alright? Oh, sorry. Let me scroll up. Okay. So now I just need to simplify it. So I'll have 2x squared minus 12x plus 3x is going to be minus 9x. 9 minus 27 is going to be negative 18.
Yeah.
Minus 18 is equal to 0. And at this point, I can find the zeros by either using the quadratic formula or I can use my calculator. So use my calculator for the last one, so let's use the quadratic formula for this one.
Okay.
Alright? So b is
Negative 9.
-9,
Becomes positive.
a is 2, and c is negative 18. So I'm going to have x is going to be equal to negative 9 plus or minus the square root of negative 9 squared
Minus 4.
minus 4 times negative 9. Yes, David?
How did you get negative 18?
That's my c term. So every trinomial, so every quadratic has an a term, 2, a b term, negative 9, and a c term, negative 18. Minus 4 times negative 9 times negative 18 all over 2 times 2. Okay? Alright. So, okay, so, and this is going to give us this is only going to give us 1, 0, so we're going to give us, this will give us two values. This is going to give us x equals 6 and x equals 3/2.
Yeah.
But the answer is only going to be x equals 3/2 because x equals 6 is extraneous. And the reason why x equals 6 is extraneous is that if you plugged x equals 6 into this denominator right here, you'd be dividing by 0. So you plug 6 into x there, you divide b by 0 at some point in the function. That's not okay.
You cannot divide by
You can't divide by 0. So x equals 6 is extraneous.
What do you mean about that? Dividing by 6?
Alright. So if x was equal to 6, that's one of the answers we got with the quadratic formula. But if we plug that into one of our terms in our function, we'd be dividing by 0, and you can't do that. So that's not going to be one of the solutions to x. Alright? And to get these, and what I would recommend for using the quadratic formula, if you're going to use the quadratic formula, is that you just plug this all into your calculator, and then evaluate it, and then use the plus sign for one, copy it, use the minus sign for the other.
How do you know if it divides by 0?
So I just know if because I got two answers when I use the quadratic formula. X equals 6 and x equals 3 halves.
Yeah.
I know x equals 6 is an extraneous solution because if I plugged x equals 6 into this denominator right here, I know that 6 minus 6 is 0. Okay? So, for 77, yes, David?
So can you get negative 18 from the bottom, like in the denominator?
Well, negative 18. I got negative 18 because I ultimately got the quadratic equation 2x squared minus 9x minus 18. And I use the quadratic formula for the quadratic ax squared plus bx plus c, alright, equals 0. And so a is equal to 2, b is equal to negative 9, and c is equal to negative 18. Yeah, so a is 2, b is negative 9, and c is negative 18. Okay? Now, 77, a car depreciates at a rate of 5.2% annually. If the car was bought for $10,000 originally, after how many years is the car worth only half its original value? So we have to plug this into an exponential function. Alright, if the car is worth half its original value, half of the original 10,000 value is going to be equal to 5,000. So we're going to have A, our amount after, is equal to our initial amount, P, times, this is exponential decay, so 1 minus our rate to the t power, okay? So we have 5,000 is equal to 10,000 times 1 minus 5.2% as a decimal is 0.052. 1 minus 0.052 to the x power. Okay? So divide each side by, divide 5,000 by 10,000, you will get 1/2 is equal to 1. So 1 minus 0.052, plug into a calculator, that should give you 0.948. 0.948 to the x power. So to solve for x, the log of 0.948, all right, of 1/2 should be equal to x. So remember, we start at the base, swoosh across the equal sign. Log of 0.948 of 1/2 equals x. All right. All right. So what happens when you put log of 0.948 of 1/2 into your calculator? You plug this into your calculator, and your answer should be 12.98 years.
Yeah, but you can't have 12.98 years.
Yeah, so that's
13
well.
years.
So yeah, you can technically have 12 point. You can have a fractional year.
Okay.
Yeah.
Yeah, okay. So
Yeah.
am I gonna find a decimal or am I gonna find like the whole number?
So you would be able to, if you got 12.98, you would be able to find what the correct answer choice is among the four. I can tell you that much. All right. So that's 2.01. Let's stop the video.